Okay, what I want to do is accuracy assessment on the classification we just did. So first, we have to come to our toolbox. Then we navigate to spatial analysis tools. Then we come to segmentation and classification, and we click on create accuracy assessment points. So what we have to do, we have to choose the image we want to classify to check the assessment. So which is this? Classify this. So the output point um, can we check? Can come to can check any of these. Can check query. So let me keep it here. So we have this. So we keep this one on classified, and we can change this to equalize, stratify, random. So for this, you can give it any number of yourself, but it's better for you to give it more number. For the case of this training, for this practice, we will just minimize this to 100. But for proper analysis, you can give it up to 1,000, 500, 600, depends on the area of your scope of work. Like I said, this so these are the so this is the result. We are not done. Next, we have to go to extraction, come to extract point values to point. So select, actually import this one. The output is the raster data that we've classified. They've also saved this too. So you can do this and maybe use this word here. True. Can save. Once we've gotten this, so we can remove this. Can remove this. So we can open to check the attribute table. So right click, go to open attribute table. So you can see what we've got. The raster values are out. Now they are out, there is something that we've not done. We need to add a longitude and latitude, the coordinates. So for we to do that, we need to go to data management, then go to features, then come to add x, y coordinates. So to do that, we'll come here, accuracy assessment point, to select that and click OK. So we allow it to process. So if you open this now, so you can see the XY coordinate of the place. So other thing we need to do, we need to arrange this, we need to arrange the classified result in the ascending order. The clean sorting ascending. So we've classified it now. So for we to carry out assessment, it is either we take it to the Google Earth or we use the true image that we've classified, the composite image, which is if we off this, so if you off this, so you can see it here. This is the true image, the true nature of the place. This is the true nature of the place. So for you to carry this assessment, we'll open the attribute table. Then we can now come to this spot for accuracy access. So if you click here, it tells us. So number one thing we need to understand, we need to check what does one represent, what does two represent in that case. So if you open this, the attribute table, one represent coral reef, two represent vegetation, three represent ocean water, four represent bare lands. So we can on this just for to access it for assessment purpose. So let's go back, open the accuracy assessment. Then we'll go back to check to start carrying out the assessment. So, so if you look very well, want to look what we've done if it's correct or not. So this is the ocean environment. So because of so we still check this is an ocean environment. Because of this is an ocean environment, the ocean reading from the attribute table, which is ocean is 24. So we'll go back and open this. So this is 24. Ocean is 24. So we have to click here, on to field calculator, and we have to say 24. Click OK. So automatically it will take its place in the ground truth. So we'll do likewise, we'll do the same thing for others. So do the same thing for others. Just to carry out the assessment properly. So correct. So we'll do the same thing to check. Correct. So it's correct. So let us that place is correct. Correct. So the truth about it is that we we are assessing all the points we've taken from the image if they are all correct. So that's what we are doing. So correct, correct. So far so good. These ones we've done first, they are correct. So what we have to do, come to field calculator, and in this case, we say 1 for 1 represent coral. So we've done that. So let us check others, the other ones from here. So from here, want to look. Okay, correct. Okay. So we just check. So my own is to my own is we have to check to carry the assessment from this point to this point to check if all those ones that is highlighted that are all highlighted, if they fall under the coral reef as mentioned as mentioned. Yes, they all fall under. So what we just do, come here and come to field calculator, and then we have one, say okay, and we are done with that. So next thing is 1515 present vegetation. We want to carry assessment if the area of vegetation. Yes. So let us look at all the 15 and see if truly they are all vegetation as assessed. Okay. There's some level of truth. Okay. Um, let us see. No, no, this is not. So, okay, I've seen the one that failed. Let me look other ones that fail. Correct. So, so, so far so good. We have, we have been able to identify just this. So let me trace. I have to check. Okay. Okay. So this one is so completely we have completely so if we do this one thing firstly identification. So can consider of it. So carry out the whole assessment. Okay. Teacher. They're all correct. Okay, they are all correct. So this vegetation, they are all correct. So field calculator 15. So we've been able to do this. So the next one is oceans. The oceans. So I will highlight all of them just to assess if what we pick is correct. Um, okay, they are correct. So 24 is the ocean. 24. So, so the next one we have to look is the bare land surface. The bare land surface. Let us look if gives us the true nature of what we yes, it's correct. Okay, it's correct. So this is field calculator 3. So we've done this now. So now that we are done with all this, so now we are done with this. What we have to do is we bring out the axis box. So we have to go back to the segmentation and classification and use the compute confusion matrix to do it. So we come back at the accuracy assessment point, then just say just matrix. Then we have this. So it comes out, being able to do this. Then we can open this, open it. So if we want to see it properly, we will have to expand this. So as you can see, this is the copper accuracy assessment. So what is in this place simply means that we have 0.986667. So if you multiply it by 100, it will be 98.67% in terms of accuracy in this analysis result, which we use coral reef in Saudi Arabia. Just a simple, we just did little work using Sentinel-2. So this is the output. So perhaps maybe you want to export this result, and what we have to do, we have to come down con to conversion. Have to go up and go to conversion. So we have Excel to table, table to Excel. We click that. I will put this. So once we did that, so the next thing we have to locate where we will save it, where we are going to export it and keep. So, so we already have this. So it will processing, processing. So we are done. So come here. It's already in this folder, so we open it. So what they are trying, what is in this place is simple. We all know that from our results, we all know that if you look at this, we all know that one indicates the coral, 15 indicates the 15 indicate the vegetation, 24 indicates the represent the what ocean water. So which we know that one is coral. So we can change this heading. Maybe if you want to show it coral reef. Okay. So this is coral reef. While this, like we said, if you look from it represents vegetation. So this is vegetation. So which can be copied, can copy it. So this, which we all know that if you come here 24, represent the what ocean water. So you can come here ocean water. So the last one is pear land. So it's the same thing if you are copying here, do this, do this, and we do this. So for we to get our final this, what we have to do for we to get the final result of this. So this is just simple, equals to this multiplied by 100. So this is the accuracy assessment, which is 98.6667%. So which is very, it's pretty nice. So So it's important to always carry out this analysis when doing image analysis, trying to carry accuracy assessment. Because like I said, we have other ways of also doing this in terms of the accuracy assessment. We can also you from this point that we've been able to do, like we use the true value, which we can also apply using the Google. We can see use the ground truth from assessment. In terms of filling the ground truth result, we use the image from the true uh, true column where we classify it. We do some classification from this, which is this. This is the true nature of the place band 432 using Sentinel 2 to do this. So it gives us the way that particular location is. Then instead of we going to Google Earth to start doing a long process, so we have to use this image. But however, in Google Earth, let me just rush through how we could use Google Earth. In Google Earth, what we have to do in Google Earth, we have to the accuracy assessment point that we've created. What we have to do in Google Earth in this case, we have to convert to come to we come to KML, layers to KML. So we click this, and we have to come here, I'll put this, and we'll save it in a new folder. So let me say new folder. Then we just say okay, it's going to save, and we'll open it using, we'll now open it. So if we want to open this, we just come here. So it's already here. We'll click on it. So it will take us down to where our samples were all derived from. So where some people don't understand. So you can see all these values, how they are all reflecting. So in this place you can see. So if we want to change, do some little adjustment, we can change the notation. Maybe we can use something of this nature, and to display the information. So you can see how it's been spread, and we can actually use this one to access. So these are one, so we can access it by checking it individually. But I think to me, it also helps to give you some level of understanding how the terrain is using Google Earth. So it tells you how the terrain is, so you know what is in that place. Accuracy assessment. So it's almost the same thing as like what we did in the nature color, the true nature color, using the appropriate band in this case. So no need coming here. We've actually done it. I just want to show you how we'll be able to do that. So, so thank you. Okay, we've done our best. Thanks.